Hey, David, can you just clarify the kinds of tools, sorry, the kinds of tools you're referring to, the ones is this
Well, I'm curious. So for instance, several of the talks talked about having deep neural networks that combined visual information with language information. And I'm curious, were people able to rely on existing tools, or did all of you have to kind of invent your own tools for that? So Cha, perhaps I'd be interested in your take on that.
Yeah. Thanks for the question. I can talk a bit about that. I think today, if you look at the community working on the cross field of vision and the language, including folks doing visual linguistics, the trend has been converging into transformer models for the sake of being very easy to train. And it happened to be after Google's work of VIT happened to be that transformer can work for visual cases very well. And so that makes the combination of visual and text language features very straightforward. You basically you put visual features in one embedding, you put language on the side by side, and then you put the transformer layer on top, and it does attention automatically, cross visual and language. And so we do see that appears to be the convergence. And we don't know, like in 5 years, this will be outdated technology also, but today I think this seems to be the trend. And then I think regarding documents, so the works like Layout-RM or Layout-M v2 takes in like position information and then maybe some image information, but I think could be a lot more that can be embedded. Extraction from, for example, Yunyao's work on tables. So table can be directly embedded into Layout-M as well. You can imagine, checkboxes or font, paragraph information, charts. All these can be embedded. And so we do see a kind of a unified framework coming up that can take all the information about documents and then come up with any understanding tasks and can solve them. Yeah.
Thank you. And any other comments on that? Is it as simple as just kind of sticking everything into a transformer?
So I have slightly different opinions on that. I think transformers can give us a starting point, but it's really important to embrace whatever domain knowledge you have. So the chemistry example I gave, it's really important to look into the graph structures of those entities and leverage the domain ontologies and databases. We have tried similar ideas for agriculture domain, and the domain specific knowledge there is quite different from chemistry. So I think maybe one solution is to use this simple solution as a starting point, and then you can incorporate structured knowledge for that domain. And maybe, graph neural network is a good way to propagate the representations. And in many of these domains, experts have already prepared a lot of resources, domain knowledge, so we should just take advantage of them. I'm a big fan of a hybrid method, and try to customize it for specific domain applications.
Okay, thank you. Any other comments on that?
I guess the approaches we use. So, for example, we are currently working on a project to document, or if you think about lectures as documents, everything that goes into a lecture, the slides, the video, the audio, and so forth. So we sort of have this hybrid approach as well, where we try as much as we can to use existing tools. We have used transformers for some of the text-related things, but in general, like because of the nature, we're trying to build, among other things, a recommender system for lecture videos, for example. So it's important to us to be able to maintain some sort of idea of the confidence of the overall prediction, and that can sometimes require a hybrid approach that takes a bunch of different modules but tries to have them communicate in the common language of probability. So if a system doesn't provide us confidence estimates, we may have to try to figure out ways to estimate confidence, maybe even using methods related to what the last speaker was talking about. So yeah, for us, we had to rely much more heavily on exactly on knowledge bases, on existing, on that sort of thing, and structured, the more fine-grained structure of the domain in integrating these multiple things. So I would say we sort of try to build a framework. We try to use existing libraries where we can. We tend to use probabilistic approaches that try to tie things together with probability and maintain confidence information across these different hybrid solutions, instead of trying to have one model that can do everything.
Okay, thank you. So, another thing that obviously was common to many of the works here, the papers as well, is the use of deep neural network based language models. And these are often, trained on massive broad scope corpora such as web data and whatnot, but document intelligence applications are often, involving specialized language, internal jargon of a company, scientific, legal language. We saw some of these examples, which may be pretty minimally represented in broad corpora. And so I'm sort of curious about, what sort of challenges that raises, and, how well do we really understand the methods for tuning? And Don, maybe I'll ask you to start, because that very much was a theme of your work.
Yeah, sure. Yeah, this is something, I mean, obviously quite relevant to a lot of the approaches that we're taking. I mean, what we find is that there's no, I think, one solution that works best here. What you can obviously do is take these, large pre-trained models. You can do some additional pre-training on a specific corpus if you want it to sort of pick up on, any sort of in-domain, knowledge that it can pick up on. So that's one standard sort of trick that you can do. Then it really depends on what resources you may have available to you. And by resources, I mean any sort of labeled data or semi sort of pseudo labeled data, and how you can use that. One of the things that we try to do is essentially think about this really from the zero shot. Just how can we take models like pre-trained models and adapt them without any knowledge, even access to the corpus potentially, right? Obviously, if you have access to the corpus, there's a lot more you can do. But yeah, it really is more of a big toolbox full of different techniques that we find are effective here, and that really there's no kind of silver bullet that solves all of these.
Other thoughts? Yeah, go ahead, Yunyao.
Yeah, so I want to point out that actually I have another talk given today in a different workshop that's talking about taming the Wild West for natural language processing. And in the entire talk, I can tell you, except for one particular paper, nothing else actually used large language model. So that's the extent of the usefulness of language model for NLP in the wild. Nothing against large language model, right? But at the same time, I want to point out, in practice, the problem related to natural language processing is very complex. We talk about a complex document, right? Like what I talk about today here in this workshop about understand table and convert documents into a machine consumable form. There we can use, we will need to use deep neural network, but natural language model is really not there yet. We're not even at the language part, right? So we need to first convert the document into something that you can apply the language model. Then the second part is often we have very small data problem. Like I don't even have enough data to train anything or fine tune, right? And also we need to customize specific thing for my own domain, from my own problem. It is possible that I can build domain specific language model, but often we don't even have unlabeled data. It's almost impossible to even fine tune the language model. So we need to think about, different kind of customization, different use cases, And then finally, explainability. A lot of time for regulatory reason, every single thing produced by the machine needs to be fully explainable, right? And also in some cases, maybe we want to have a way to be able to easily incorporate user feedback, and that will call for a completely transparent model. So I think what we have heard from everybody else, right? Everybody in practice use hybrid model. Yes, we use BERT, we saw BERT and the other transformer-based model everywhere in all the applications, but in the real world, it's very different. I think we really need to understand the problem itself, like begin with the why, right? Why we build this model, and then second is to understand how do we evaluate that particular model we build, and then lastly is to think about what method. Yeah, so in my mind, you know, whatever model is really the last thing. We need to understand the first two, especially the first question first, like why we build this.
Okay, well, thank you. This is a good controversial thing to hear here, and one that I'm very sympathetic to myself as a skeptic about large language models. So does anybody else weigh in on the importance of gigantic language models in document intelligence applications?
Just to, you know, again, I'm also, you know, a big believer in everything, you know, that was just said, right? It really comes down to sort of understanding the problem. So I'm not gonna, you know, argue for giant LMs, even though, you know, Google we love our language models here, and our transformers, right? But that being said, you know, at the end of the day, when it comes to, you know, like there's the research and pushing the research agenda, and when it comes to the natural language understanding and machine learning and all of that, but then there's the reality of the situation, right? And you know, I think that, you know, you really have to, like I mentioned, this toolbox has a lot of different things in it. It's not just like a toolbox full of different language models that you then sort of piece together. So fully agree on the, you know, kind of understand the problem, the value of it, and you know, sometimes you have to go, you know, and just and sometimes heuristics and, you know, ad hoc types of approaches are really what you need here. That being said, there is, I think, a lot of really interesting things with the large language models and their abilities for doing the zero and few shot learning that that's sort of, you know, we have not seen before, and this is kind of an interesting time to explore that. And, you know, these it will sort of change the way that things are done, but I do feel that we're just at the precipice of that understanding.
All right. Anybody else want to weigh in on pro versus anti on role of, or something more nuanced on role of very large language models in practical deployed systems?
Yeah, I can add a few more. I think large language models certainly has its use. I think it's actually very powerful, probably more powerful than I think we probably are actually in the stage of still seeking kind of applications. One example, for example, you know, those big models like GPT-3, they are actually fantastic for producing synthetic data for training. So we talk about, you know, short of data, and you know, these big model, having seen billions of text characters, they're actually a fantastic tool to just produce synthetic data for training. You know, if your data is limited, you can do something like that. So I'm kind of a believer. I think that's the direction we're heading to, and that's yeah, I think there's a huge potential in that.
Yeah, I don't disagree. There's huge potential, and we use it ourselves too, right? But I think everything has a place. I think the one thing, maybe it's a paper. If you haven't read it, I recommend everybody to read it. It's a very recent ACL funding paper about I don't remember exact title now, but it's more about understanding the adaptation and application of NLP. I think it's very important for all of us, right, as researchers, to point out to everyone else that there is no magic solution. not language model, not anything. There is no one single solution for anything. And anytime we talk about superhuman performance and so on, we have to be very careful, because for people who are not experts, they just heard those things and they thought everything already solved by GPT-3. I think we need to be very careful when we make this kind of statement.
Thank you. Any other comments on that? Okay, so another topic that we brought up, which is a kind of complex and rambling topic, is evaluation. And obviously, all of you talked about evaluations in a lot of different fashions, and it's a topic near and dear to my heart. I guess sort of first question I have is, what's the role of, what do you see in a document intelligence application, which often involves obviously many component stages, but often also extracting many different types of information, which have different notions of correctness. What do you see as the role of component evaluations versus sort of, end-to-end, some sort of business oriented evaluation metric?
So I want to jump on that, because I actually developed a product with our product team on PDF conversion. And this is precisely the problem we have encountered. I would say we need to develop evaluation for different purpose. We need actually both. What we did, for example, for document conversion, we defined over 80 different metrics. And there are different categories. One category is to help the model developers to understand the performance of their model and identify places for improvement. Then another category is to communicate to the stakeholders. And those metrics are more communicating from the end user point of view. What kind of performance they can expect. I think we need both. One major challenge is the data set. How can we create data set that is actually enable this kind of evaluation, and also tools that allows us to look at the results and identify ways to make the improvement.
Hey, thank you. So actually, Heng, I'm curious, have you gotten feedback from chemists yet? I mean, I know your project is at a very early stage, but do you have a sense of, what their kind of error metrics are, or the way they would think about, would this make this useful to me? What kinds of errors are tolerable? What kinds of errors are just, embarrassing? I'd be curious about that.
Yeah, so we are playing with the chemists almost every day. And I think the most valuable feedback we got so far is not just about performance level, but rather how can we exactly do the utility evaluation, right? Like, for example, the reaction prediction one, I'm personally very excited, because I mean, my ambitious goal is to be able to replace some of these scientists, right? Like completely just replace them. And they don't believe that's going to happen. So they keep suggesting us some more conservative, more lower level task. So for example, instead of predicting reactions, they want to give us those top 20 reactions candidates they already came up. They just simply ask us to search for literature for evidence. So that kind of thing is very boring to us, right? Because it's not cool and we cannot publish it, but it's extremely useful for them. So we are kind of trying to, deal with this kind of trade-off. Like we don't want to lose the users, right? We want to have some platform that they will be using every day. And in the meanwhile, we can have some techniques that we can publish in CS, conferences and journals. And I would say other things, we should maybe more open-minded, try to think broadly, going beyond precision record or any probing evaluation. So for example, in the agriculture domain, what we're doing now is actually to integrate our system with robots. So like the robots can really learn from our knowledge base and do real things, like they can cut the corns or pick berries, and then we can then measure, we can quantify the amount of time we can save for them. So I think the low-level intrinsic evaluation can help us make sure our system's not buggy, right? But if we don't deliver the real platform, like Yunyao said, the really useful tools, then the systems written in our papers will definitely die, like after 5 years or 6 years. There will be something better to come up, right? There will always some newer deep learning algorithms coming out. Yeah, I'm holding this very practical view after I worked with them. Yeah.
Well, thank you. There, actually, you said at least two really kind of fascinating, provocative things there, which I will come back to later. But I do want to kind of continue on the theme of, sort of component evaluations versus end-to-end style evaluations. So Don, one of the things that struck me about your talk was, when I think of Google, I sort of envy you, and if you've got all the data in the world, you're in the best possible position for evaluating anything you want, and yet your talk was very much about, gosh, we can maybe get a little data from consumer users, but corporate users we can't get anything from, and so we're in this kind of data stage. And I'm going like, geez, if Google is data starved, I mean, how could anybody do anything? So I guess I'm kind of curious about your take on the sort of component versus end-to-end evaluations.
Yeah, I mean, it's even more challenging, right? Again, it's sort of as this third-party service, provider for all of these enterprises, right? We don't have just one customer up in the drive case, right? We don't have 10. We have, many, right? And so, and each of them has their own idea of what success looks like, what they want, right? And so the thing is that, you get a lot of feedback. Usually it's negative feedback in terms of, hey, this does not work in this way. We want this to do this. We have this feature request, that feature request. And so it becomes this, this challenge. And then you try to, work with somebody and say, well, okay, we understand your feature request. Would you be willing to maybe partner with us to help build this out? And maybe, you can provide some labeled data or some insight. And then it's like, no, whoa, we want you to provide this awesome service, but we don't want to help, right, at all. So it is really kind of a tension, and it's really, really, really challenging. And so it's often difficult even to build sort of the simplest things like a document classifier, even over consumer data, right? And in those cases, what we can do is go and find raters, ask them to look at their own documents, and we can build things. But then when it comes to evaluating the system that we were to say launch it, you'd have to then figure out a way of doing that using kind of like more of implicit feedback. And if something goes wrong, how do you debug? You can't look at the data unless you get explicit permission from the user to look at their data. So this makes things, even Gmail search, which is, a tough problem there. We still don't even know what is the full range of email search queries that are out there, just because of privacy reasons. We could look at the head. We know what the top, the tokens that go above the K anonymity requirements are, right? People search for their CV, and they search for like dentists and their Facebook stuff, but then the tail, which is super long, no idea what's in there, and it's really, really hard. So yeah, so that's one case, is the third-party case, which is insanely difficult. The other one is more recently, we're getting into these sort of building like things like the Biomed Explorer. We're working with individual companies. They're, again, like no two companies are the same, and we're learning that, like for building these systems, some people want to do, systematic reviews where recall is super important. You need to find every single, relevant document. And others, like, we don't really care about that. We want, like question answering capability. So I think the fact that this is just, there's such a diverse set of needs, it makes it really challenging. And it would be nice, like, actually, I would love to be in the situation where it's like, there's one corpus, there's one thing that we're building, and you can, do whatever you want with that data. But often that is not the case.
So it would seem like IBM and Microsoft are probably in kind of similar situations in the sense that you're very interested in building tools for people whose data you don't own. Chai, Yunyao, either you want to comment on that? All right, we'll pick Cha first.
I think, yeah, you can go first.
No, that's fine.
Yeah, okay. So yeah, for Microsoft, yeah, we have the same issue. I think data has always been an issue for us, particularly for document intelligence. Talking about any data type, let's say invoice, receipts, ID documents, business card, all these contain a lot of PII, personal identifier information. And these are all sensitive and against Microsoft policy to collect any of these data. And so it's very challenging to collect any data. And this is not even easy to get anybody agree, sign a contract to say, yeah, you can use this data, because yeah, they're just difficult to get. So, and that's why I was talking quite a bit about synthetic data, and that's sort of our route. See if we can use that route to produce some data that looks like the real one, but works reasonable, and we can train a model out of it. So.
Okay, Yunyao, IBM, same problem.
Yeah, same problem. So I think for most of the services we have, right, especially for document conversion, I would say basically we only see a very small corner of the universe, but we need to build something work for the entire universe. I think there are a few ways we're kind of tackle the problem. The first thing is, we can try to generate synthetic data, right? Try to build a model that is as general as possible, and really pay attention to the out of domain performance rather than try to optimize for in-domain performance. And the second part is really enable customization. Like, for example, I showed an example today, right, for the table understanding, for the table extraction part. And it's the same pretty much for everything else. Empower our users to fine-tune the performance or whatever we build for their performance is another very important aspect.
All right. Well, actually, you're all making me feel better because I work for a software company in the legal technology space, and I always feel very frustrated that our customers are applying our software to this very confidential documents and legal cases that we don't get to see. And I've been envying all of you at these companies that actually are holding the data, but I guess you don't have access to it either. So actually, I feel much better now.
Yeah, it's the same. Like, the kind of data we have to deal with are also highly confidential. Like, we also deal with like procurement contract, right? Invoices, all those things are not something they're going to share with us.
So actually, maybe all of us then who work for companies should be envying Kevyn and Heng because academics, you all can do anything you want, right? So you probably are just rolling in data. Is that right, Kevyn?
That's yeah. Well, actually, yeah, it's interesting. I was at Microsoft for many years, including working on search algorithms. Had access to all that data. It was great. And then when I moved to academia, at first I was like, all these problems I'm interested in, is that going to transfer? It turns out actually that, as everybody knows, the amount of data that is being gathered now in software used in educational settings is just exploding, especially with the growth of online courses. So I've been involved. So for me, I've always been interested in personalization, for example, and so now I've developed several popular courses on Coursera, for example, and it's great to feel like I'm helping students learn about machine learning. But we also use these platforms to do to experiment and to understand, students. So we've actually been able to get a large amount of very rich data, and then within the university, it takes a bit of doing and a bit of sweet talking with some of the IT people to get them to sort of make things fit together, with some diverse systems. But once you do that, you get an incredibly rich picture for the kinds of educational recommendation systems and things that I like to work on. There's an incredibly rich set of data. It's not necessarily a huge fire hose of queries, but it's smaller, but it's much more it's much richer, heterogeneous. So that's been an interesting challenge for me. So we've used online systems to do evaluation. We've run Coursera. We worked pretty well with Coursera to develop randomized controlled trials, A/B testing, to evaluate the effectiveness of different algorithms. So to that extent, I've been able to solve some of my evaluation issues when it comes to algorithms in educational settings, just by virtue of the increasing popularity of these online platforms. And then that often will then translate to the algorithms that I'll use for some of the small, like the residential courses.
Okay, thank you.
So I'm actually doing 20% for Amazon, so I'm not like totally academic. I really appreciate the freedom and the openness I'm having in academic world. I mean, especially after I started working for Amazon, I even just for 20%. On the academic side, I do feel we have a lot of problems that industry people don't have. For example, our data sets is usually not very representative of the real world problems, right? So if we work on 50 news documents about bombing, we cannot apply that system for Alexa for sure, because people are not interested in, those entities. They are only interested in songs and movies. And also we don't have that millions of users who can do A/B test or give us feedback, right? So if industry friends can share, maybe, I don't know, de-anonymize some of your data and make a way to share with academic people, I think the grad students will learn a lot, and then they can contribute to the progress of this area. Yeah, it's very hard. I mean, I learned a lot after I joined Amazon. It's a very tedious process, the legal issues, things like that. But I think we needed that kind of shared task and data sets to push forward this area.
Great, thank you. Are there other comments that people have about sort of data and evaluation issues in document intelligence?
So I want to make a quick comment follow up on what Heng is saying, right? I think it is completely true that industry research need to do more to help guide the academic researchers towards the right direction. So over the years, we actually try to, whenever possible, try to release as much data as possible, especially data for evaluation. Because we cannot just blame people, especially the students, right? To say you work on the wrong problem and you are evaluating with the wrong metrics. We need to help them with all our knowledge and also our resources so that people are spending energy on the right problem and evaluate the systems the right way.
So I'm curious about, you said something I thought was very provocative, Heng Ji, which is that the things that some of the things that the chemists would like you to work on would not be publishable. And I'm curious, both actually from the entire panel, about, is there a way in which document intelligence tasks are almost, because of their various, their practicality and the fact that they have to deal with the data as they are, right? It's not sort of nice data that's particularly easy to do, language processing or image processing or anything. I mean, but almost by definition, you have to deal with the enterprise data as it is. Is there a sense in which that makes the data, makes the things that you have to do uninteresting to academics, difficult to publish. I'm curious about people's experiences with that.
So I actually have a question for Heng. So have you thought about submit your paper to, for example, industry track, right? Either KDD or NACO or even IAI. Would that be some venue that the work could be published?
Yeah, so yeah, industry track definitely is a good option. And we were also advised by the chemists. There are some journals with ACM, for example, ACM journal on computational chemistry. Those are good venues. But sometimes we also kind of want to get feedback from computer scientists in terms of our algorithms. So maybe it's just time to create a new journal or new conference for that domain. Yeah, some of my colleagues are trying to hire some, special professional engineers, and they can translate some of our fancy code, and then they will do the lower level engineering work. Maybe that's the way to go. Yeah.
Kevin, looked like you had a comment.
Yeah, just a brief comment. So the way that we have sort of dealt with that at university is we actually have, hundreds of students, a lot of hundreds of master students, even, not to mention many undergrads. We teach courses in how to do those kinds of things, and so we've had good success in for a lot of that sort of the initial work, the data cleaning and preparation, all that stuff, which is not necessarily research, but it's very important. We've used those as opportunities for student teams for projects. We have a whole internal sort of client center, and so if chemists or whoever come and say we have these data sets, we want to do X, Y, and Z, and we do a lot of sort of document intelligence related things, then we parcel that work into work on, we say a team of master students will work on it, on this problem in conjunction with a faculty member. So we try to, so I think for us anyway, those kinds of problems that are more engineering related, that's a good learning opportunity that we try to leverage for students.
So yeah, so actually it seems like it's a good point. There's at least two different issues here. One is simply getting the work done, and whether that's hiring the right personnel or finding opportunities for students to do things, and then there's the question of are there things that once you're working in the document intelligence area, are there problems that you find to be interesting research problems, but the rest of what you would think of as your academic community doesn't think of them as interesting research problems? And I guess are the current mechanisms we have, applied tracks, or an applied version of a conference, or publishing in a not in a computer science journal, but maybe in a domain area journal, do people feel that these mechanisms we have are sufficient to let you publish the things that you actually think are interesting research?
I usually feel happy in that situation. That's when I started working on like text readability, for example. There was nobody else that was working in that area. I'm not that they didn't think it was important, but I think, I don't know. I don't know that we, I mean, as far as document understanding and intelligence, I think it's important to have a community like this one that comes at it from different angles, because I do think it's a multimodal problem that where there are a lot of interesting new things that come up that are sort of fall between the cracks of some of the existing sort of problem domains. So I think it's in workshops like this one actually where you can find the new problems that nobody else is doing. I don't know what else. I think conferences in general are receptive to new things. Maybe I should just say that. Maybe not, but I don't know. I mean, from my personal experience, I haven't had too much of a problem, getting the new things published. It's getting that traction initially that's can be difficult.
Yeah, and I guess I'm at the point of my career that I should not care too much about number of papers anymore. So it's, and the way to measure success is not just about how many ACL papers we get every year, right? So if I have a runnable system platform that all the chemists are using on a daily basis, I don't care about how many papers I publish or how many citations. So I think it's a way to kind of think about what is real impact, right? Yeah, so like Kevin said, setting up a new workshop is really maybe the most promising way to go. That's how bio-NLP community was built up about 15 years ago. Like they start from some really small workshop, and then hundreds of people start to do the one test together, and now it's becoming a really big thing every year in the ACL conferences. So I think if this domain, this application becomes something that academic or students really find interesting, and that they have resource to try, then we can still publish at this machine learning and NLP conferences.
Yeah, I want to add a bit about, in companies, I think, so in the inside company at Microsoft, we have Microsoft Research, which is more the research branch of the company, and they are more free to publish, right? So majority of the work that I present today actually came out from MSR, and majority of them has been published, and I think that part is fine. But then we also have the part that actually build the product. And so things I mentioned, like building an invoice, a parser, a receipt understanding engine, API. I mean, of course, briefly I can say, well, we're using Layout OM, but actually, how do we use Layout OM to actually do the work? There's still quite a lot of details, and I do believe many of these details do worth publication. Just example, for example, invoice. Invoice, how do you get the line items of invoice, which involves not just a simple layout. It contains table information first. You need to pass the table properly. And many of these layout the line item tables are actually extremely complicated. And so they have item descriptions, and some of them break into like indented tables where you need to pass them properly. So the applied scientists on the product side, they're working on actually making a product that ship. And then when I ask them, like, okay, would you like to publish a paper? And the answer usually is like after they ship the product, they don't really have the incentive to publish a paper because they need to do extra work for publishing a paper. They need to take the algorithm, run some existing public data set, because if you're running on internal data set, nobody will accept the paper because it's just you don't share the data. But also, like on the academia side, there's not many existing public data set that is really that good, and so this additional work feels like testing with a toy data set that doesn't worth trying. And so they don't have really that much motivation to publish on those parts. And so so even inside the company, I would see there's different scenarios.
Yeah, so I'm gonna do a little bit of advertisement here. I think you should really consider submit to industry tracks such as NACO or KDD applied science track, because it's completely different review form. And we explicitly remove the requirement of doing comparison with the other baseline, because we understand in industry setting or in applied science setting, you may have data that is not accessible externally, and then it doesn't make sense for people to go through all the trouble, just try to have a paper, prove the very, very obvious points. Okay, yeah. So please consider submit, because for this year, for example, I was chairing the NACO industry track. We got 1/3 of submission from Amazon, but not too many submissions from Microsoft. I hope that'll change next year.
Okay, that's pretty funny. All right, I think you've been called out there, right? let the MSR people know about that, right? So so this is I guess then as a question about you know, I think one of the big changes that we've seen in industrial research over the years is that you see many more people getting not just even a master's degree, but even like a PhD in computer science, but then going into what are very clearly development positions. But during their PhD career, they do have to publish things, and so is it is it safe to be sort of encouraging graduate students to work on document intelligence tasks? Like, will they be able to publish? I think Yunyao, you're suggesting that they should publish in the ACL applied track, right? But in general, do we feel like there's enough of a publishing ecosystem that a graduate student can say do a PhD in a document intelligence kind of task and feel like there's a place to publish along the way?
So I think it's the advisor's responsibility to be able to sell the work and design, frame it in a way that it doesn't look like just a system demo. So I always tell my students who are working on this AI chemistry center that they should keep thinking about hypothesis, research hypothesis, rather than the scores for information rejection or reaction prediction. Like, what are the research problems you're trying to answer? And that kind of challenges are independent of the domain you're working on. So yeah, so I think another advantage is this kind of document intelligence applications can let them attract more interdisciplinary positions, even if they want to become professor. So many of them are really interested in that kind of challenge. I don't see any big, disadvantage by working on this domain. So several of my students have ACL papers this year. They usually need to do things like what Chad said about maybe duplicate something on another shared task. For example, if they find this external knowledge can help chemistry IE, they have to maybe do the same thing for another bio NLP shared task, so that reviewers will see that table about performance comparison. So if the academic track can do something similar like what Yunyao said for industry track, I think that will solve the problem. Because nowadays reviewers still care about comparison. You need to present a huge table comparing with the 10 papers published from last year. I think we should in general, we should encourage more like this kind of frontier, like pioneering work, like problem definition, formulation, rather than comparing with SOTA 1% or 2%. Yeah.
Other comments on this? This is your opportunity to complain about state-of-the-art comparisons.
Oh, I was just going to make a comment about there are some differences, I suppose, between universities. Like Carnegie Mellon, for example, where I got my PhD, viewed system building as a first class research activity. Other departments don't necessarily take that view. But yeah, I mean, for my own students, I say, focus on interesting things that you're curious about, the research questions. I guess my own style is I tend to try to look for, in document intelligence, it's such a fascinating problem. There are lots of ways where the problems that come up can then lead to, it shows that there are gaps in current NLP technology or gaps in current machine learning. So I guess I tend to, a lot of my work goes from machine learning and NLP, toward the problem, but I also like to try to see about if there's work that can go in the other direction. And part of it depends on who the student is and what they'd like to do. But I think there are opportunities to give back to the machine learning community. because sometimes, yeah, those problems can lead to interesting realization that new areas of machine learning or NLP, for example. So that's one of the things I like about this area.
Great, thank you. So, obviously the world is full of AI meetings right now that you could spend every day of the year going to a different, AI meeting. And so, one thing I always like to think about is we've now had 2 document intelligence workshops. Is this workshop filling a need that is not met by other conferences?
Yeah, I would say definitely yes. Because my team, actually most of my team working on natural language processing problems, right? But then for the particular problem we work on document conversion is kind of at the intersection of natural language processing, computer vision, and machine learning. And for the papers we submit, it's kind of difficult to find a community. I think you can get it accepted at different places, but then every single time you are a minority, you don't see other people working on the same problem. I think this particular workshop really serves that need for the people working on the problem to come together and discuss further. Like this kind of panel, right, will not be possible in any other place.
I have a concrete suggestion. I think we probably want to put some more punchy title in the workshop, because when I saw the email from Ben, I mean, I immediately said yes because Ben's a good friend, but I actually have no idea what the workshop is about. So I have to read all the call for papers and look at the published paper titles, and then go, oh, this is what you're asking for. I thought that he was asking me to talk about information injection for missing information or something. So maybe something like, if I want to sell this to my NLP students, I would say this is something about beyond language modeling or something like that. Like document intelligence is quite a big, I mean, to me.
I think, Ben, we may need to hire a marketing firm here to give us some advice. All right. Any other comments on is this workshop needed?
So before I went back to school, I actually was a member of a group called the ePaper group at Microsoft Research. I was a software developer in that group, and the charter of that group was essentially document intelligence, and we did a lot of work with OCR, automatic recognition of lots of different things related to documents. And in that group was Gary Starkweather, who was he was the inventor of the laser printer. Amazing guy to be able to work with. And I talked with him about document intelligence and why it was an interesting area. And he said, documents that people produce, documents are works of art. There's this sort of endless variety and richness, and they're produced by people and to communicate. And he saw it as a very rich domain for experimentation, and a lot could be done in that area for decades. And I agreed with him. And I think for me, like just the evidence from all the different talks that I've seen, my talk about what's difficult about information in the document, and from the questions and discussions, it has to do with the text, with the pictures, could have to do with the structure, the scientific clarity of the table presentations, anything to do with, so from my point of view, in trying to understand the nature of difficulty and how to account for that in information systems, it's been fascinating. And because I've been able to see all these different perspectives, different modalities, different ways of thinking about, like the logical structure, like that Ben's talk about law, legal situations and so forth. And then just having to have work on lecture understanding. One of my current projects, I'm seeing all these different tools that people are talking about in your talks, APIs and things, and all those need to be brought to bear on this problem. And that's what I'm finding in a lot of these problems I'm working on now, is that there's a need to unify diverse sources of types of documents even. So and that leads to interesting new optimization and search and recommended problems. So I think from my point of view, like it gives perfect sort of set of diverse views on a central research problem of mine, as an example.
Great, thank you. Are there any questions from the audience? And you can either speak up or you can put questions in chat. And I guess while we're waiting for that, any final comments from the panel members?
I have one question.
Okay.
Yeah, it seems to me that most focus in this workshop, at least, is on the understanding of documents side. What about the generation side?
Good point. Anybody want to comment on generating documents?
So we had a system called Paper Robot last year. It can write biomedical papers automatically. It's a very fancy idea, and CS people like it, but biomedical researchers are never going to use it. So we stopped working on that. I think maybe a more practical, more useful direction is what Charles suggested, maybe use generation as a way to generate training data for this kind of mining, knowledge discovery algorithms. Yeah.
But how about the angle of like authoring assist? So if you're writing a paper, would it be good that your tool offers suggestion? Here is where you should insert a chart and basically just write a chart for you. Or here is the table you need to insert, right? That kind of stuff.
Yeah, so actually when we published our system, we got a lot more interest from foreign speakers. So that, they already have the ideas of that paper, they already have experimental results, they just need help to write things into a nice English document. Yeah, so definitely some interactive tool, I think will be very helpful. Yeah, that's a really nice idea.
Yeah, so I actually have similar experience as him. Not as a project I was involved in personally, but a project from my team. So they were working on automatically generating slides from documents. It also published in NACO this year. I think it's also a demo paper. But again, when we try to talk to our offering management, talking to different people, nobody seems to actually can see any actual usage of the tool. I think people are still hesitating to leverage automatic generated document. I think the trouble they have to go through, proofread what generated by machine and edit it over that is just not worth the trouble.
Yeah, so actually, we just did a survey of students asking about systems that can recommend good material for you to study from, or could to summarize lectures. So one of the top features requested by students was actually an automatically generated summary of lectures as a study guide. That was like the second, number one, number two, or number three or something. So, and I think there are interesting possibilities for automatic summarization, and it's connected to business needs and meetings. So we talk to people about what we're doing, get people saying, oh, well, we have these meetings and we'd love to be able to summarize the meetings. And that brings together the slides, it brings together comments and chat or whatever. And then the other comment I was going to make was, because you mentioned editing, when we're working on these models of document complexity and quality, especially in terms of lectures, that's one of the applications, is to turn it around and give a tool to instructors to say, hey, do you know, you're talking to students about this abstract thing, maybe you should introduce a concrete example of that thing to help them out, or you forgot to define this important concept. So a lot of the models that you can use to model and understand the complexity can be turned around and used as tools to improve, as a quality measure, or to improve the quality when a person is involved. So I'm very interested in that.
Great, thank you. Okay, we've reached time, people. Thank you so much for participating in the panel. I know it's been a long day, but I hope the conversation was of interest to everyone. So thank you. And over to you, Ben.
All right, thank you. Let me stop recording.